The most popular model used to establish open communication between two systems is the Open Systems Interface, or OSI model, proposed by the International Organization for Standardization. OSI is a reference model that describes how information from a software application in one computer moves through a physical medium to the software application in another computer. OSI consists of 7 layers, and each layer performs a particular network function. The OSI model divides the whole task into 7 smaller and manageable tasks. Each layer is assigned a particular task. Each layer is self-contained so that tasks assigned to each layer can be performed independently. There are 7 OSI layers, and each layer has different functions. We'll begin by listing the various layers, then we'll progress to discussing what each one does. We have the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. There are many mnemonic techniques and phrases that help people to remember these layers, but my preferred one is, please do not tell secret passwords anytime. I take passwords very seriously, so that kind of resonates with me. You're free to find your own mnemonic, whatever helps you to remember that. You notice that with this particular phrase, the first letter of each word in this sentence corresponds in order from 1 to 7 to a specific OSI model layer. These layers are provided by a mixture of network card drivers, operating systems, applications and networking hardware that facilitates the transmission of signals over Ethernet, fiber optic, or other wireless protocols. We'll describe the layers from top to bottom. The application layer, or layer 7, is the layer that most users will interact with and recognize. The application layer provides network services to the end user. These services are protocols that work with the data the client is using. Protocols like FTP, HTTP, SMTP, and more. The most common is the HTTP that is widely used with web browsers such as Google Chrome, Firefox, and Internet Explorer. Other examples of applications that use this layer are Office, Outlook, and Skype. All of these interactive applications provide a set of services that allow the application layer to supply and receive data from the presentation layer. The presentation layer, or layer 6, performs the uncomplicated task of syntax processing, or the act of converting data from one format to another. For example, imagine you are ordering something from an online store. These transactions are typically handled in a secure transmission, which means that the data passing between the store or website application will transmit encrypted data to the presentation layer that will need to be decrypted and processed. This layer handles translating the data from the top layer, which is presented in the application format, to network format and vice versa. After the presentation layer processes the data from one format to another, the information is then passed to the session layer or the application layer, depending on whether the data is transmitting or receiving. At the session layer, or layer 5, the construction, direction, and conclusion of connections between devices occur. This layer supports multiple types of connections, as well as being responsible for the authentication and reconnection if a network interruption should occur. After the session is established, the data then passes to or from the transport layer. The transport layer, or layer 4, is responsible for the transmission of data across network connections. This layer coordinates how much data to send, how fast, where it goes, and things like this. Of the most widely known protocols for internet applications, these services may be provided by Transmission Control Protocol, TCP, or User Datagram Protocol, known as UDP. Other protocols may provide additional capabilities, including error recovery, data flow, and retransmission. Once the transport layer has completed its function, the data is now passed to or from the network layer. The network layer, or layer 3, handles the management of network traffic by using IP addressing and routing. Examples include IPv4, IPv6, and ICMP, the ping protocol. Here, we're using source and destination IP addressing for delivery. After the data arrives at this layer, each frame of data is examined to conclude if the data has reached its ultimate target. The layer sends data to the correct destination on outgoing transmissions and receives incoming transmissions as well. The IP portion of TCP or IP is a commonly known network layer for the Internet. This layer also manages the mapping between logical addresses and physical addresses. For IP addresses, this is accomplished through Address Resolution Protocol or ARP. The data is then passed to the next required layer, which is the data link layer. The data link layer or layer 2 is considered the most complex of the layers. This layer is often divided into sub-layers called Media Access Control, MAC, or Logical Link Control, LLC. This layer sets up links across the physical network. When this layer receives data from the physical layer, it checks for transmission errors and then packages the bits into data frames. From there, this layer manages the physical addressing methods for the MAC or LLC layers. An example of the MAC layer includes 802.11 wireless specifications as well as Ethernet. At the data link layer, the data passes to or from the final layer in the OSI model, which is the physical layer. The physical layer or layer 1 is the electrical or physical layer of the model. This layer encompasses network cables, power plugs, cable pinouts, wireless radio frequencies, connectors, transceivers, receivers, repeaters, buses of light, electric voltages, and more. When troubleshooting problems, this is typically the first place to start. Is the device plugged in? Is the wireless card working? Is there a cut on the cable? At this layer, the modem transmits the digital bits from the source or sending device's physical layer over network communication media, which can be electrical, mechanical, or radio, to the receiving or destination device's physical layer. The OSI model is commonly referred to by network engineers, particularly the first 3 layers. When you hear about layer 1 issues, layer 2 issues, layer 3 issues, you want to know what those mean and exactly what you would find in each layer. This is essential in this course.